Hey guys, what's up? Welcome back to another episode for the ULR. I know in the last video I was going to work on the JIT compiler, but then I just started scrolling through like some of my old source, and I realized that like they're missing stuff. For example, here it has a host native assembly, but if I go into like the actual like whatever user interface, there's no host JIT assembly, and so I figured maybe in this video I'll just go through some of this and implement some of this stuff. I have no idea what's going on here. I really don't want to commit this, but I'm just gonna say add breakpoint. By the way, my commit history is like horrible. It's like extremely ugly. But whatever. Add a breakpoint in. What is that? Loadjit ASO. Who cares? Who cares? You know what? Come to think of it, I don't think I've ever like formally learned source control practices. I've just like, version control practices. I've just done it. Okay. Why is this? Oh, what did I do? Okay, so it looks like I'm going to implement a host JIT assembly, and this will allow us, instead of like whenever I want to test some JIT code, instead of having to like load it manually and call a function from this, I can just call it straight from, or I can just load a JIT assembly straight up. But then there will be one thing I need to add, which is, wait, so what's going on? Alright, I'll just copy this. There will be one thing I need to add, which is an entry point directive for IL, which I don't think exists as of now. Oh, and I should also do IL dependencies. Let me just make sure this is in my right, and then, okay. I don't really know. Right. This is what I'm doing right now. And then have, I don't know why this entire thing's to do. I don't know what. Have JIT entry point directive. Cool. So take the assembly name, debugger path, standard lib path, arg count, and the argument vector as like the native C vector. So I handle access violation. Cool. Oh, there's also an issue with this with get stack trace, but I'm not gonna bother. Load the debugger. So I need to remove some of these to-dos because they're not relevant anymore. Yeah, this is never happening. Wait, what? This is an object. Oh, loader. Yeah, that's never happening. This may actually cause leaks. Okay, that's gonna be the second thing I'm working on. Fix the leaks. My to-dos are just everywhere. There's like the to-do document. There's like random comments. Horrible organization. But anyways, so I get the debugger module. Cool. Debugger not found. That works. Yep. Native loader. Invalid. Write the array assembly. Initialize internal library. Load the standard library. And now load the assembly. So instead of this, I just want to do internal API to load JIT assembly, and then I'll just say assembly name, and then res. Wait, what's res? It's a ULR result. So that's what that returns. Okay, so yeah, I kind of want to refactor this. there, like in that way I can like return the result. So wait, first I'm gonna add a code for, okay, so invalid assembly that exists. So then I want to refactor this. This is gonna be a breaking change, but what I can do is, so I'll make this a, wait, yeah, I will make this a, if ULR result is here, that's a hosting result. Where is ULR result defined? T result, okay, so that works. So this is a ULR result of assembly. So that's what I'll just do. I'll just make this return a ULR result of assembly. And then I'll just change the test to work. So yep, incompatible with declaration. So I'll go to resolver. And where is it? Wait, I should make all of these ULR results. That might be this video. Who knows? Instead of returning null pointers, or like bare null pointers. So this is not going to be a thing. It's just going to get the error if the JIT thing got compiled or whatever, and then it's going to, wait, actually, now I want to return the compilation error as well. Bruh. Okay, how about this? I'm going to extend ULR result again. We're going to go to assembly. The ULR result is going to be, take another type name, T error info, and then this is going to be, I don't know, what's like a placeholder type? It'll be like char. Is this legal, C++? I've never done default templating arguments before. I think it's legal. But for some reason, this extension is like weird. Just, okay. Wait, like if I do this, yeah, expected a type specifier. Okay. T error info, and this will pad, so like it doesn't matter what type this is. So T error info, error info, and then based on this, like based on whatever is returned, like you'll know if there's extra info. Now this is going to return a null assembly and an error, which is going to be, what do I call this? Wait, so this should return ULR result of assembly with extra error info of JIT compilation error. So JIT or IL compilation error. So this should return an error which is invalid assembly, and then error should be perfect, right? Yep, compilation error, invalid assembly, perfect, and then I can delete this. So I just propagate the error. Okay. Otherwise it just returns this and null. I could leave them undefined, but wait. Could I leave them undefined? Oh wait, no, I have to put none here. I have to put none. Right. And then I could leave their thing undefined, but whatever. Let me just be explicit. And I have to update the declaration once again. And now everything should work. Stop complaining. How is it incompatible? Okay, good. Yeah, dude, C++, such a heavy language that trying to work with it in like VS Code, the extension just registers everything so late. Okay. So now we have our auto res is equal to this. Alright. Then, dude, I have like 3 result classes now. If res dot error, then I want to, that's the same thing I did up here, right? If res dot error returns 0, res dot error. Yeah. Return 0, res dot error. So hosting result returns rect code. Yeah. Okay. So I return the error, propagate the error back to the caller, and then I have the JIT assembly, so I don't need this. Then the main assembly, yep, it's gonna be that. If the entry is a null pointer, return entry not found. Otherwise, initialize args. Right, perfect. That's from the native library, by the way, which I showcased in the last video. So make the string from the literal. I could also just use local API. Let me just use local API. Avoid dereferencing. Doesn't matter, but consistency's sake. Wait, error type. Are you kidding? Oh, you know why? Because no, IL is defined. Perfect type. Now what type is this? Now why does it say, this doesn't, oh yeah, this doesn't include, because UIL needs a resolver, right? Right. So how can I do this now? Wait, does it need a resolver? Can I uninclude this? I just unincluded it, nothing broke. It needs a resolver because it needs the implementation. So something would have broken, I'm not sure why. It didn't break. Wait. This might still work, because if worst comes to worst, I'll just move the declaration down. So this no longer has access to it. I don't know why it's. Oh wait, no. Okay. I will move compilation error. I'll move that. And then wait, let me just. I'll move it to assembly. And then I'll do yeah, right here. Namespace IL, like it's right here anyways. Let me actually copy this down for, wait, no. I don't know what I'm doing now. Okay. Okay, cool. Now this all works. Bring it back. Perfect. Load entry point not found. Generate the argument vector as a ULR array. If there's an error there, return it. Otherwise, assign the array I got the right code. Okay, this thing, cursed GC shenanigans, it's going to be removed. Main assembly entry, and that's it. And then deallocate. Oh wait, I wonder if I ever free the memory that the JIT compiler has allocated. I think I do, because the API has a JIT context that it deletes, and this thing deletes. Yeah, it does. Okay. And then I wanted to do one last thing, which was fix that possible memory leakage. So up here, this may actually cause leaks. Have a ULR cleanup function, which is called before returning. Okay, yeah. So ULR cleanup, and I'll just do void ULR cleanup. I don't know why I'm doing different naming conventions. But I'll say I'm gonna make these all internal. So I'll host native xm internal, and I'll make the internal function ULR cleanup. Yeah, I've been like flipping between Pascal case and snake case. Wait, this is a host JIT assembly one. Yeah. See, that's the thing. Why wasn't my compiler throwing errors when I had two functions named the same exact thing? So ULR cleanup should do this, free the library, free the debugger. Should do all of this. How can it get access to the debugger? It can do it through ULR API. So internal API. Debugger, H module debugger. Where does it get put? If debugger, init debugger equals get proc address. Ah, okay. So I need to expose the debugger somehow, which is, I'll just make it a public field, which, yeah, whatever. My philosophy is if you shouldn't be touching the public field, you shouldn't be touching the public field. So realistically, who cares? I'm like changing this whole API anyways, so yeah. So just free that, or maybe not, you know, I'm going back on my word. Yeah, that's getting deleted. Okay. So instead of freeing this, we'll just have a global variable for it. Equals and then free module debugger, and then yeah, each assembly free equals null. So I'll just free it right here. H module is a pointer type, right? H instance declare handle. What does this do? I'm not trying to interpret that macro right now. So I'll just free the global debugger, or yeah, this will be the only use for this thing, just so I can free it at the end. Everything else is good except for local API, which I can thankfully access through this pointer. Yeah. Yeah, so this ULR API object, this is like, when I was originally writing the framework, this was basically the communicator between native code and the runtime. So basically this class basically holds the logic of the runtime, essentially. And then all ULR host does is it just launches a process and creates an instance of this class and passes it to the assembly. But this thing basically, this thing and the loader like are the runtime. So like they do all the stuff. So wait, why don't I just make this in a ULR API destructor? Whatever. Host native assembly internal. So now we're going to, I'm going to delete all this, and then I'm going to basically centralize everything. So wait, what is, oh, it's just resetting it to 0. I don't know. Okay. So then if I collapse, and I collapse, oh, wait, one thing I need to do is say global, wait, debugger global. It's a good debugger. I just realized some things in the cleanup function might crash if they're not initialized yet. But I think free libraries shouldn't crash if you pass it a null pointer, right? I don't know. I'll figure that out later. Cool. Okay. So now I just make those functions again. So these things are not going to be extern C's anymore. Same signature though. So these things are going to be the internal functions. And then all it's going to do is going to be auto res is equal to host native assembly internal assembly name debugger path standard live path argc full and argv full. And then we're going to ULR cleanup and then return res. And then this should avoid leaks if like there's an error. Host JIT assembly, that takes the same args, right? Yep, same args. And then host JIT assembly internal, it'll just be the same code. Oh, it's right here. Host JIT assembly internal. Perfect. I feel like there's some duplicate code going on. But there it is. Now all that's left to do is just make sure I didn't break anything. And then I'll do, yeah, I need to fix this because it's like scripts run test, but it's really just recompiling because it doesn't actually run the .NET executable that like pipes all this stuff together. Whoa. Okay, I think I did something wrong. Right, that's from the JIT compiler. I hope I didn't screw something up because I don't think there's. Okay, so it's basically like what? Guys, why is this an issue? What did I delete? Hello? Yeah, why is this? Alright, actually, instead of doing that, I will delete, or I'll take this stuff off. Come on. Can it do some like function sorting on its own? Alright, I swear there were less. Conflicting declaration auto res. Ah, yes. Okay, so auto. Yeah, that could have been bad. I'm glad there's an error for it. Cannot convert. Right. So one more fix because I changed the API. And since they know this will work, I'm not going to check for an error. I'm just going to get the result. Perfect. Then I can just run the .NET executable. So I'll do ULR bin net 8.0. Am I on? Oh, debug net 8.0. ULR.exe. We're going to run a native assembly, copy the relative path, or I should probably do, yep. Or actually, I just realized my command line option for n doesn't take anything. It's just that the DLL is like whatever arguments left over. It's like a positional argument. The n is just supposed to be a flag. But then the debugger, yeah, I don't remember, so I'm just going to take the whole thing. Perfect. And then PCMath adder class. Perfect. Continue. Oh yeah, okay. So it executed. That must be the code I just wrote. So hopefully nothing too bad. Let me just, for internal API allocated objects, free. So I think I could run GDB on this. Let me see. I hate having to go back here. I wonder if there's a better way to do this. Alright. Oh, okay. How do I pass GDB args again? Amazing. Do I have to do it in run? No, I can do the args parameter. But at this point, what am I doing? I'm going all the way back. Okay. Args. Okay. So run. Continue. So backtrace. We don't know where we are. It was from free from line 62, so I probably freed a false pointer. Then I don't see how this could be false though. Unless I accidentally freed twice. Cool, did all this. Return. Did all this. Return. Just clean up. Just clean up. Free. Looks like I'm gonna have to do some old style debug. Wait, no. Break ULR host .cpp. I didn't see, every time I don't think it's gonna take me that long, I make some dumb mistake, and it always takes me very long. Alright, run. Yes. C. Okay, breakpoint. Wow. I lock. Entry. First is Fifi. Ah. So something was corrupt. Wow. Also, yeah, sometimes GDB breaks. Like, what is going on here? Is this something to do with the fact that I just made it in a different function? Oh, it is. Oh, I'm so dumb. Bro, I'm actually so dumb. I allocated the flipping API inside of, like, locally. Okay, I'm gonna just make it an object, because I mean, it can be an object. I don't see why it can't be an object. Yep, so much for local API. Right, it's gonna be an object. And then I can just, since I have the cleanup function anyway, I can literally just replace, or I can just delete it then. Yeah, and I'm just gonna have to dereference this, whatever. Okay. So now it's not destroyed. And then I can do delete internal API. Perfect. And you know what? I really should have put all this. You know what? I'm going to do it now. I'm going to put all of the deallocation stuff just in the deletion of internal API. And now I'm realizing this is dumb. And the reason it's dumb is because now I'm just like changing up the entire structure again, where I don't need like this separate cleanup function anymore, because it's going to be this destructor. But you know what? Let's go ahead with it, because this is a much better design. I'll just make a new file for this. Wait, why is it not auto-completing it? Perfect. So then in the resolver, there will be a private reference to the debugger. So all of this was just wasted design for me. And wow. Oh, and my cache system thing doesn't like take into account header files, so it'll like mess up the source, because this will shift all the offsets of these properties. So I have to like delete my cache, which is another reason for me to switch to a build system. And now I can just copy all this. So I should really just revert all my code to before I made the ULR cleanup function. Because this is going to auto delete everything. Beautiful. Host name assembly and host JIT assembly. And resolver cleanup, we'll just free the debugger. I hope I didn't control Z too much. Free this, and then allocated generic placeholders. And then, yeah, I should have made a loader class too as well. Because then I would be able to, like, offload this logic. But I'm just going to do this for now. Because, wait. This is a class or namespace name. Oh, wait, sorry. Wait, what? No, name followed by this must be class. That's not true. No, that's not true. What? Loader? Ah, loader's not implemented here. Wow. Really bad design. Should have made loader a class. Should have made loader a class. You know what? It's not too late. It's not too late. We're extending the video. Extending the video even longer to make loader a class. Because I don't know why it was a namespace. It was just like bad design on my part. Standard map. Yep, standard map. And no extern, please. This is going to be some public fields. Public fields. And then these are all going to be definitions. Or declarations, rather. And then, right, little semicolon. And then for the loader.cpp, we're going to change this, and then we're going to delete these. Then we're going to do loader, and just append loader, or sorry, prepend loader to all these names. I'm going to collapse this. Collapse. I should make use of region and end region to make this easier. Oh yeah, this vtable. I'm going to make a whole another video on the vtable. We're going to fix it from the ground up because it is broken in its entirety. It's just broken. Can I include loader? Oh, please, wait. This might be bad. Oh, good. Oh, perfect. I can include the loader. Right? That's not circular. Yeah, it's not circular. Perfect. So then instead of taking all of these, I can just take the loader in. Loader. That's all I need now. I can delete this. I can delete this. And I can delete this. And I can just say loader. I'll just make this public because some of the fields are public. Loader. Perfect. Let me see if this still brings me over. Nope, too late. Okay. I'll just take in loader. And then I'll say this loader is equal to loader. So much loader. Yep, I forgot this is going to be bad. Whew, a lot of undefined references. So I have to do loader, loaded assemblies count, and then loader read assemblies. Cool, now I know what to replace. Operator applied to that instead of a pointer type. Because it's a map. Okay. So say say assemblies should be, or let me replace read assemblies first. Should be loader read assemblies dot place all. Then assemblies that should be loader loaded assemblies dot. Okay, I replaced some things. And then should be, loader load native assembly. Or loader. And then there's a read native assembly. And then that was a red one, right? Yeah. Red assemblies and then load assemblies, and no need for the deref again anymore, I mean. Alright, so then I'll just do search for that, and that's going to be loader loaded assemblies, and then red assemblies, and then this is just going to be loader populate vtable. I mean, yeah, I'm gonna change that thing anyways. A lot of resolver code because, as I said before, it's basically the runtime. So yep, and then loader allocate generic placeholders. Perfect. And then we just include windows. Man, you can never go wrong with including windows. That's actually wrong. You can go very wrong with including windows. Because this might be in debug help. Yeah, it's in debug help. Yep. Okay. It might work now. It might work. And instead we're just going to create a new loader object. New loader. Yep. And then we'll just make this guy responsible for cleaning up loader as well. No. Wait, no. We just won't give it anything. Holy. We'll just make it create the loader itself. New loader. Oh my gosh. What's going on at the bottom? Nothing. And then it won't take in the loader. It'll just take in this stuff. Quick. I can't go over there anymore. Nope. resolver.cpp. Remove that. Alright, it's created the new loader. That's perfect. And now we're just going to do, now we just have to change some of these. So local API.loader dot red assemblies. Oh. No. I actually changed the infrastructure for this as well, so I'm just going to do loader dot loaded assemblies. Man, lots of code. So this is so easy to break, like so easy to break. I feel like I'm gonna break something very badly. And then I can delete all of this cleanup code because the API thing, object thing handles it in its destructor now. So all I have to do is local API.loader I mean, I guess I could use the API method to load these, but that's fine. See, that one thing that said perhaps refactor loader into an object one day, well, that day is today, and it was refactored. Okay, so let me delete that and that. Man, I don't know how long I've even been recording. I've just been going on tangents every time I find something awry. Okay, now everything should work. Quit, yes. I did not recompile. Let me just recompile it. Right. I need to delete the cache because I changed a bunch of stuff in the header. Debug cache it is. Just gonna recompile everything. Watch those object files get generated on the left. Method info, member info. Oh, method info. I spent a lot when I was first making like the native stuff. I spent a lot of time here, like especially for invoke. Bro, invoke took so long, and then later I made constructor info invoke. Yeah, invoke, dude, so long. I was using inline assembly. Oh my god, it was so bad to like try to pass this arguments, and it's like there's like C code executing in between it, right? So I had to like carefully pin stuff in different places so that the C code wouldn't interfere with the inline assembly. It was like, instead of writing like now with the JIT compiler, I could just like compile a JIT delegate and have it call the method, but nah. Back then, only native, it sucked. Alright, here, class has no member named assemblies. Ah, now the JIT compiler's like broken. Okay. Loaded assemblies. Loader red assemblies. Wait, I swear. Oh, okay, maybe I ruined something in here. Okay, I thought I made stuff like get removed from red assemblies when it got loaded, but I might be wrong, so I'm gonna keep it there for now and check that later. And then, okay, let me just make a note. Normalize red loaded assemblies. And then this thing in compile type. Oh, so it did use a loader vtable population. Okay, so I can. Okay. That is weird, very odd. So then my vtable stuff might work. It's just I have to not get cooked. Right. I fix this afterwards, so it makes sense that this error's back. And then I can clear the cache again because stuff broke. Okay, so I think my vtable code might work. I'll just make the vtable such that it uses the name, so the JIT compiler can use the name to look up. Nope, never mind, still undefined. Undefined reference to ULR loader populate vtable. Did I not make that a loader method? I did. No reference is found. So I probably did not. No reference is found. Let me go here. Okay, so it's bugging out. But undefined reference to ULR loader read native assembly. Oh wait, you know what's bad? I can't even tell if this is the old one or not. No, these are new. Yeah, these are new. Wait, I don't know why. This is the class. Yeah, this is the loader class. It has these functions. Why is there no undefined reference? Error, no such file directory. Unused variable. Whatever. Let me remove that. It's getting slightly annoying. So the loader classes, I always hate linker errors, man. Especially in C++. There's like, the names, man, they're too long. Let me see what's in the... you know what? I'm moving loader, so loader should be part of lib, like the lib compilation. Top 10 reasons why you should get a build system. This is like the 7th thing. The 7th reason, you know, I should have gotten one, but I'm going to do that and then change my compile script. So the compile script is not going to use this. It's going to, loader is going to be in, yep, not here. Top 10 reasons. Now this should all compile. Should generate a loader object. Hopefully. Nice. Create a loader object. No errors? No errors? Yes. Okay, cool. Now we can run the .NET thing. Goes into ULD. Print the methods. Continue. Perfect. Alright. We're done. Finally. Adding one method turned into refactoring half of the runtime loader and API. But thank you guys for watching. This went a lot longer than I wanted it to. But thanks for watching, and I'll see you in the next one.